So chapter 3, part 5 is about reading a chemical formula and then calculating the molar mass of a compound. So you first have to know what a subscript is. So a subscript is a small number in size, not necessarily quantity, that shows how many atoms of an element are present. And this number will follow a symbol, a chemical symbol. And it's always a whole number. So for example, C6H12O11. That means there's 6 C's, 6 carbons, 12 H's, 12 hydrogen, 11 O's, 11 oxygens. If there isn't a subscript, for example, CO2, it is assumed that the subscript is a 1. So C1, 1 carbon, 2 oxygens, O2. We do not write the subscript 1 though. So we do not write the left side. We do not write the right side. This would be incorrect. You would write it without the 1 subscript. So looking at this chemical formula, H2SO4, or you could say hydrogen sulfate, sulfuric acid, how many hydrogens are there? So you have to look at the number that follows the element. So H has 2. How many S's? Well, there's no subscript, so we assume it's a 1, and then 4 O's. So every symbol has its own number. Sometimes it's a little bit complicated and you have a set of parentheses. So if you have a set of parentheses and there's a number outside of the parenthesis, you have to multiply it by everything inside. And the front parenthesis is like a barrier. So you have to multiply, you have to distribute. So in this case, we have NaNO23 would be how you read that. So how many sodiums? Well, there's no subscript there. So we assume it's a 1. Technically, for right now, there's 1 nitrogen here, and there's technically 2 oxygens, but we have this 3 on the outside. So we have to take 3 times 2, gives us a total of 6 oxygens, and then we do 3 times 1, which gives us a total of 3 nitrogens. And this acts like a barrier, so we stop there. We do not multiply it by the Na. What about here? So we've got 2 aluminum. We have a 3 on the outside of the parenthesis. We have to multiply it by everything inside. So we did have 1 sulfur times 3 gives us 3 sulfur. And we had 4 oxygen times 3 gives us 12 oxygen. Make sure you're multiplying. What about this one? Well, we have 1 calcium. There was 1 carbon here times 2 gives us a total of 2 carbons. And there was 3 oxygen. But once again, 3 times 2 is 6 oxygen. So if there's something outside the parentheses, it gets multiplied by everything inside. All right, so what is molar mass then? Molar mass is the sum of the mass of each atom of an element within a compound. So you first have to know how many atoms of each element are present. You have to know the atomic mass from your periodic table, and then you find the sum. And the unit for molar mass is grams over moles written out, or you can abbreviate G over MOL. So for example, we have H2SO4. So you first have to figure out how many of each element are present. According to the subscripts, we have 2 H's, we have 1 S, and we have 4 O's. Now you have to look at your periodic table. Remember, I put a copy of this in the notes and lecture video folder. It's there. You can also just look one up on the internet. Usually you're going to find a decimal number. If it's rounded, that's okay, but if you have a decimal, you can also round it as long as it's rounded appropriately. So on the periodic table, I have my atomic mass of hydrogen as 1.0079. I'm finding that in the box for hydrogen. I'm going to round that to just 1. So as long as you round appropriately, it's okay. Just don't over round up or down. And I'm going to look at sulfur's box. Sulfur's atomic mass is 32.066. I'm going to round that to 32.01. You can leave it as is. And oxygen is 15.999. I'm going to round that to 16. So I'm saying that 1 hydrogen has a mass of about 1, One sulfur has a mass of about 32, and one oxygen has a mass of about 16. But then I need to take how many of those atoms are present times the actual mass. So 2 times 1 gives me a total mass of hydrogen of 2. 1 times 32.01 gives me a total mass of sulfur in this compound as 32.01. And 4 times 16 gives me 64. That gives me a total mass of oxygen in this compound about 64. Then you have to add these numbers together to get the sum of all of them. So 64 plus 32.01 plus 2, I get about 98.01 grams over moles. That is the atomic mass, that is the molar mass of H2SO4. So it's not hard to do, but you need to make sure you're counting the atoms appropriately. You need to make sure you're looking at the right box and rounding appropriately for atomic mass, and then make sure your math is correct. All right, let's try another one. We'll try this one. So how many of each atom are present? Well, we have 2 aluminum. I have 3 sulfur because I'm distributing, and I have 12 oxygen because I'm distributing. That just came from the subscripts, the compound formula. All right, looking at my periodic table, the atomic mass of aluminum is 26.982. I'm going to round that to 27. Sulfur, once again, I'm going to go 32. And oxygen, I'm going to go 16. So I got that from the periodic table. Then we're going to multiply. 27 times 2, I get 54. 32 times 3 is 96. And 12 times 16, 192. So that's each individual element. 54 is the mass of total aluminum in this compound. 96 is the total mass of sulfur in this compound. And oxygen is the total mass of, 192 is the total mass of oxygen in this compound. But I want to know the atomic mass of the molar mass of the entire compound. So I'm going to add all of those together. So 192 plus 96 plus 54. Make sure you're actually doing your math right in your calculator. And I get 342 grams over moles. That is the atomic mass of this compound. Let's try another one. Try this one. So I've got 1 sodium, 1 oxygen, 1 hydrogen. No subscripts, meaning it's assumed it's a 1. According to my periodic table, sodium is about 22.99. I'm going to round it to 23. If your numbers are slightly different than mine because of rounding, that's perfectly fine. Just don't over-round or under-round. I'm going to round oxygen up to 16 and round H down to 1. So 23 times 1 is 23. 16 times 1 is 16. And 1 times 1 is 1. Add those all together to get the total sum of all the masses. 23 plus 16 plus 1. I get that the molar mass of NaOH, sodium hydroxide, is about 40 grams over moles. If you got something a little tiny bit different, that's fine. All right, try this one. Pause the video, try it yourself, and then I'll put the answer up. So you should have 1 calcium because this 2 does not go past the first parenthesis. You should have 2 oxygen from distributing, and you should have 2 hydrogen from distributing. Calcium is about 40 from my periodic table, oxygen about 60, hydrogen about 1. Add those together. I get about 73 grams over moles for CaOH2, which is calcium hydroxide. What about this one? Did I skip one? Nope. Okay. What about this one? Looks hard. It's not. It's just more work. More elements. 1 sodium, 2 carbon, 3 hydrogen, 2 oxygen. No parentheses, just using the subscripts. Sodium is about 23. Carbon's about 12. You do not have to round these. You can use right off your periodic table. That's perfectly fine. Oops, look, I made a mistake. See, this is why you need to check. I have 15 for oxygen, but it's 15.999. So I have to round that up to 16 if I'm going to round. Okay, adding all the masses. And you have to show some work. You gotta show me something. You can't just give me an answer. I get 82 grams per mole for this compound. All right, let's see what's next. All right, 2 more. Let's go a little more complicated. So I've got 1 magnesium, 2 carbon, 6 hydrogen, 3 times 2 is 6, 4 oxygen. Okay, magnesium is about 24.305. So I'm just going to leave that one. Carbon's about 12, hydrogen about 1, oxygen about, whoops, I almost did it again, about 16. Make sure your math is right. It's not hard math. But if you mess it up, it's hard for me to give you partial credit. All right, adding those all together, 64 plus 6 plus 24 plus 24.305. And I get a molar mass of 118.305. If you just gave me 118, I would accept it. If you gave me 118.31, I would accept it. Close enough. All right, last one. This is pretty much as complicated as I can get. Okay, I have a radical first in parentheses with a subscript on the outside. Once again, you're only distributing it inside the parenthesis. So I've got 3 nitrogen and 4 times 3, 12 hydrogen. And then I've got 6 carbon, 5 hydrogen, 7 oxygen. So nitrogen's about 14. Notice I have hydrogen in 2 spots. You could either do them separate, 12 hydrogen and then 5 hydrogen, or you could add together and say there's 17. It's whatever works for you. You shouldn't be getting massive numbers, even if it's a big compound. Your numbers still shouldn't be out of control. All right, adding those all together, I get 243 grams over mole. Don't forget the unit. It counts for half a point every time. So that is molar mass. Counting atoms using subscripts, distributing when appropriate, and then finding the molar mass of a compound.